One of the problems with AI is that the same inputs will often yield different outcomes. Let me show you how to fix that.
I built bots before they were cool.
We tend to think of AI systems as software, but they don't behave like traditional software. Traditional software is deterministic. Given the same input and instruction, we expect the same output every time, just like a calculator. However, AI is non-deterministic. The same prompt will produce a different result every time you use it. So at this point, I want to point out that there are two similar words with slightly different meanings. Nondeterminism is the computer science term that we're going to be discussing in this video. Indeterminism is a philosophic term that means that events are not completely determined by prior causes. For AI purposes, the correct word is non-deterministic. In traditional software, control is based on explicit logic. Basically, when conditions are like this, we'll always do that. This predictability is the only reason we trust computers to manage pacemakers, X-ray machines, avionics, tax returns, or automotive systems. Traditional software is so predictable that on its own, it is totally unable to create a random number. Whereas AI says, given your prompt and my training, this is probably the best thing to do next. This is why we don't use AI to control cars. Just imagine an airbag controller thinking, there's an 82% probability that deploying the airbag is the most appropriate response. AI uses millions and millions of inputs and probabilities, so the range of possible outcomes is enormous, virtually infinite. And that is essentially how language models work. The problem begins when you need the flexibility of AI to interface with a traditional deterministic system. So here's a real-world example. Let's say that you want to create an application where you can upload all of your paper receipts and automatically submit a monthly expense report. The problem is that you travel a lot and your receipts come from many different businesses, different countries, using different systems for measuring taxes and currency and whatnot. For example, look at these two receipts. We have one receipt here from a grocery store, and you can see there's a great number of items and actually quite a bit of data on this receipt. And then we have this receipt from a gas station where it looks like somebody bought some gasoline and a pack of gum. Now, to a parser, these are very different documents. I've written many parsers in my time, and parsing ambiguous data like this is really quite difficult. AI, however, is really good at this. The problem is getting AI to return information in a predictable format every time, regardless of the receipt. This is where JSON comes in. Here's how you solve this problem. The first thing I did is I uploaded the most data-rich and complex receipt, and I asked AI to create a JSON representation of the attached receipt. Then I took that JSON that AI supplied, and I asked it to remove all the parametric values. This essentially creates a template. Now, I could have gone in and edited this manually. It's just so much easier to have AI do it. So now we've got a template, and now we can give AI that JSON structure to our first receipt and tell it to repopulate the structure. So here's the prompt. Here's all the information on the receipt, but here it's in a predictable format. We can do this 20 times and we'll get the same result each time. Now let's do the same thing for the smaller receipt. So again, here's the smaller receipt. Here is the prompt, and it's essentially the same prompt. This receipt had fewer parameters, but AI was able to fill out what it found. As long as the known parameters were presented in a known structure, we get back very similar looking results that we had with the more complex receipt. As it is, I asked ChatGPT to identify the common parameters between these two receipts, and it actually found 29. Again, these are very different receipts, but there is a lot of data and a lot of metadata that they share. The grocery receipt and the gas station receipt contain completely different transactions, yet both were converted into the same machine-readable structure, that JSON that we developed earlier. The gas station receipt required different item instances, but we don't need to reinvent a new format. Those varying length lists are easily accommodated with a JSON array. That's why we're using JSON as a data structure and not a spreadsheet. Spreadsheets can't handle varying amounts of relational data. So this is the important part. We let AI do what AI is good at, interpret language, understand ambiguous information, and basically classify things and extract meaning. And then we constrain the result with JSON. This structure can be validated, unexpected parameters can be rejected, required parameters can be checked, and once the data passes validation, traditional deterministic software can take over from there. So the process is basically this. When you need to process unstructured data, let AI interpret it, constrain it with JSON, and then let your deterministic systems digest the structured data. While this book describes structured prompts, this method structures your output. The AI can be probabilistic on the inside. The rest of your system doesn't have to be. And that is a much more solvable engineering problem. If you like this kind of content, give a like and subscribe. Come back later. Bye-bye.